All right, today we're diving into a fascinating story where some really futuristic tech is solving a very expensive, very real problem. We're going to see how quantum computing is finally stepping out of the lab and into the real world to crack a puzzle that could save millions. So picture this. Imagine you're trying to find something super valuable, but it's buried deep underground. The only way you can look for it is to drill a hole. But here's the catch. Every single time you drill, it costs a small fortune. So how do you pick the absolute best spots to learn the most without completely blowing your budget? That's the huge challenge we're tackling. And, this isn't just some fun thought experiment. This is the day-to-day reality for anyone in geological surveying. Whether you're planning a massive construction project, searching for natural resources, or even checking on environmental risks, you have to know what's going on under your feet. And that means you're basically playing a very, very high-stakes guessing game. And when I say high stakes, I mean it. Just look at this number. Every single sample, every little hole you drill, can cost around $1,000. Now, think about a big project. You might need dozens, maybe hundreds of these things. The costs just explode, spiraling into tens or even hundreds of thousands of dollars. Fast. So this creates this classic massive dilemma, right? You've got a tight budget, but you have to get the most information possible. You can't just drill everywhere. And if you put your sensors too close to each other, you're literally just paying twice for the exact same information. The whole challenge, the real trick, is finding that perfect sweet spot, the absolute best placement to learn the most while spending the least. So how has this problem been handled up to now? Well, for years, people have relied on what we call classical methods, or heuristics. You can just think of these as common sense rules of thumb. They're logical, they're step-by-step, and they're designed to find a pretty good solution, but almost never the perfect one. Let's look at a couple of the most common ones. First, there's the greedy approach. It's simple. You just find the single best-looking spot, pick it, then find the next best one, and so on. Then there's top K, where you just rank all the promising spots and pick, say, the top 5. They make sense, but they've got a huge flaw. They never see the whole picture at once. They can easily miss the absolute best combination of spots. But what if you could change the game completely? What if, instead of just trying to make the old methods a little better, you used a fundamentally new tool? Well, this is where quantum optimization comes in. It's a totally different way of searching for an answer. The specific tool we're talking about is an algorithm called QAOA. Now, don't worry about the crazy name or the physics behind it. The easiest way to think of QAOA is as a super-powered search engine. While your regular computer checks possibilities one after another, a quantum algorithm like this can look at a massive landscape of potential solutions all at the same time to find the true optimal answer. So what mission did the researchers give this quantum search engine? They gave it 3 really clear instructions. First, get the most information possible. Second, penalize any answers where the sensors are too close together and just gathering repetitive data. And third, do all of that without going over budget. Simple as that. Okay, so the theory sounds amazing, but does this thing actually work? Well, to find out, researchers put the quantum approach to the test. They ran a head-to-head simulation against those old, traditional methods. It was time for a showdown. So on one side, you have the classic methods, making their decisions one step at a time. But the quantum approach, it's on another level. QAOA doesn't think sequentially. It looks at the entire problem, all the possible combinations, all at once to find the absolute best pattern. It's not about finding the best individual players, it's about finding the best possible team. And here is the truly wild part. This incredibly complicated calculation, sorting through a huge number of possibilities to find that one perfect combination, the simulation did it all in less than 1 second. So what did that 1-second simulation actually find? Okay, let's get to the results, because this is where you can really see the power of this new way of thinking. I mean, the results kind of speak for themselves, don't they? This chart shows an information coverage score, basically how much good, useful data was collected. The old methods, they scored a 2.7. The quantum approach, it scored a 5.0. That's not just a little bit better, that is a massive leap forward. Let's just put a hard number on that improvement. The quantum solution gave them an 85% boost in the quality of the information they gathered. 85% for the exact same number of sensors. You're getting almost double the value for your money. So what does an 85% improvement look like in dollars and cents? Well, for this one simulation, it translated to a direct savings of over 2,500 bucks. The quantum plan was just so much more efficient. And you have to remember, this was for one single, small, simulated project. Imagine scaling this up. This is way more than just a cool simulation. This is a perfect example of what people in the industry call quantum advantage. It's that tipping point where this new technology isn't just an interesting idea anymore, it's actually practically better at solving a real-world problem. And that could change how all kinds of major projects get done. So what's the bottom line here? It's pretty clear. Quantum optimization can seriously slash costs. It lets you make decisions faster and with way more confidence because the data you're working with is just flat out better. And maybe the most important part, this scales. The bigger and more complex the project, the more time and money a quantum approach is going to save. So we started with this really specific puzzle about where to drill holes in the ground. But what we've really just seen is quantum computing delivering a solution that's smarter, faster, and cheaper for a real business problem. It really makes you wonder, doesn't it? If it can find the hidden patterns here, what other huge, seemingly impossible problems in things like logistics or medicine or finance are just sitting there, waiting for a quantum solution to unlock them?